Thinking it would be fun, you climb on top of the school to throw water balloons at the teachers as they arrive to work in the morning. This time, you're going to throw the balloons down at the teachers with a speed of 12 meters per second. How long do the teachers have to get out of the way if you're on the roof 10 meters above them? So again, we have our picture drawn. The balloon's displacement is going to be 10 meters down, so that'll be negative 10 meters. The acceleration is always down, negative 9.8 meters per second squared. But unlike the last time we did a problem similar to this where we dropped it, now we're giving it an initial velocity that's down 12 meters per second. So we pull our numbers out, displacement, negative 10 meters. Initial velocity is negative 12 meters per second. Acceleration, negative 9.8 meters per second squared. And time is our question mark. We're going to pick the equation that does not have VF in it, since that's my blank spot. And that's going to be D equals V naught T plus 1/2 AT squared. We've done a problem like this before where V naught was 0, so this term was able to cancel out and go away. Made our math a little bit easier. That's not the case in this one. This one, we're going to have to use the quadratic formula because we have T in two different spots and one of them is squared. If you don't remember, the quadratic formula was any equation that's in the form 0 equals A x squared plus bx plus c. We'd pull the A, the B, and the C out, whatever numbers those happen to be, and we would say, okay, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what I need to do is turn this equation into one that looks like this. So I got to get 0 to one side. So ultimately, I'm just going to subtract the d over. And I'm just going to flip-flop these two terms, move the 1/2 at squared over to the left. I can rearrange things that I'm adding. That's okay. That's allowed in math. So I'm going to subtract the d over, and that's going to leave me with 0 equals, I'm going to write this term first, 1/2 acceleration t squared plus v naught t minus d. So when I'm plugging into my quadratic formula, the negative b and b squared, 4ac all over 2a, what's my a, what's my b, what's my c? 1/2 acceleration would be my a term. V naught would be everywhere you see a b, you plug in the value for v naught. And because it's minus d, as opposed to plus c, it's minus. So negative d, so it would actually be a negative 10, so positive 10, is what we plug in everywhere we see the letter c. Now, if I were to plug all of that stuff in, and instead of x equals, it would be time equals, what I would get is time equals negative v naught plus or minus the square root of v naught squared plus 2ad all over acceleration. The reason why this plus instead of the minus that was here is because the negative d that was going to go in, I just moved the negative out and the two negatives canceled each other. It was 4 times the a term. Well, a is a half acceleration. So the 4, well, if you do that with the half, turns into a 2. And in the bottom, 2a, well, a is 1/2 acceleration, so the half and the 2 cancel, leaving you with that. So anytime that you have to do the quadratic formula for the third kinematics equation of d equals v naught t plus 1/2 at squared, this is going to be the way it looks. If you want to write that down on your equation sheet, you're more than welcome to do so. Now we can plug in our numbers and we can solve some stuff. So t equals negative v naught. Well, v naught is already a negative 12, so a negative of a negative is just a positive, so I can just put 12 meters per second plus or minus. I'm going to hold off on the square root just so I know how long everything is here. It's going to be a negative 12 meters per second. That's going to get squared. That's my v naught squared there. Plus 2 times negative 9.8 meters per second squared times d is negative 10 meters. So I'm just plugging in my acceleration number, and my d, which is that negative 10, and that's all underneath the square root symbol. And then I'm going to divide that by a, which is still negative 9.8 meters per second squared. If I plug all of that into my calculator, if you're familiar with the quadratic formula, because of this plus or minus, I'm actually going to get two numbers coming out. I could get that the teachers have negative 3.1 seconds to get out of the way, or the teachers have 0.66 seconds to get out of the way. Now in math class, you'd probably keep both numbers because both numbers could theoretically be real or possible for whatever the function is that you're doing, but this is physics class and we are only interested in reality. So the teachers do not have to travel back in time to get out of the way of this thing. We don't worry about negative times. Negative times are answers that can be completely and totally ignored. So the reality is the teachers have 0.66 seconds to get out of the way before that thing, water balloon in this case, hits them in the head.